All right, it's 10 a.m. Good morning, everyone. Thank you for joining another edition of the Long Coffee Break. Want to welcome David DeRocher or D. Roche this morning to be co-hosting with me, presenting, going over harmonics with Yaskawa. So with that, I will let David take it over and do your thing.
All right, thanks, Mike. I'll go ahead and hop in here. So again, my name is David DeRocher. I'm the regional drive specialist for Yaskawa for VFDs here in the Rocky Mountain states. So today I wanted to go over harmonic mitigation with our two main HVAC drives that Yaskawa offers. These include the HV600 and Z1000U. So the agenda, I want to cover some applications of VFDs, a little bit of VFD basics, just in case maybe you're not familiar with the type of unit. We'll get into harmonic basics and then harmonic mitigation, and finally discuss that Z1000U model as well. So first of all, this Yaskawa America, we do three main divisions: drives, motion, and robotics. Again, I'm just on the drive side as that one division, but again, you can see the VFDs, we do servos, and then these cool robots too. So that's kind of fun. We're up in Waukegan, Illinois, and then also based in Buffalo Grove and Oak Creek, Wisconsin for our factories. Product description. So we got the HV600 over here on the right, and then the Z1000U on the far right. And so these VFDs are variable frequency drives used for a variety of building automation applications. And generally, you're going to be running those variable torque loads like fans, water pumps, in your cooling towers, compressors, condenser fans, and chillers. So just to get into what actually makes up a variable frequency drive and, what is it really used for here? So a contactor, if you were just to run a motor across the line, like for a fan, you'd be looking at two choices, either 0 or 60 hertz. It's on or it's off. And so a VFD kind of takes that to a whole nother level, and you can do anywhere in between 0 all the way up to 400 hertz if your application requires it. Most of the time it won't, but it is nice to at least have that much variable speed control within your device. So it could run, typically anywhere between 0 and 60. And again, that's just controlling your speed. And then this results in energy savings, less mechanical stress on your system. And additionally, you have the opportunity for network connectivity with your VFDs. So that's super helpful. Just to talk about why they save energy. So it has to do with the type of load I was discussing called a variable torque load, where the amount of power that you're going to put into a pump or a fan to make it run is not going to be directly have a linear relationship with how much electrical power it's using. So like the flow rate in torque are kind of listed here. And then so what you can see is as you drop a small amount in flow rate, let's say by 30%, you're actually going to reduce the power consumption by about 65%. So in these HVAC systems that don't often need 100% fan speed, you have the opportunity to save a lot of power by decreasing your flow rate just a little bit. And so, a small change in speed results in a large change in power there. Just getting into, so now we kind of know, that there's these power saving benefits, network connectivity. Wanted to talk about the user interface on these things. Certainly it can be kind of a black box for people if you haven't programmed a VFD before. Yaskawa's goal is to make the complicated simple. And so our button and interface has been updated over the last couple of years. And so the HV600 has the newest LCD display screen. And basically, we just put everything up front and center. Got an alarm LED indicator, LCD display large enough that displays all of your different parameter groups. And then up, down arrow keys. And these are all quite tactile feel in the buttons. So if you're using gloves or something, it's fairly easy to still use the keypad and feel when you're actually pressing a button. And again there, so that's a kind of a sample screen of, you would have your frequency reference of, hey, I want to set my drive to this many hertz. And then you've got your output frequency of what the motor is actually going to run at. So going back to the network connectivity part, these are the kinds of protocols that can be incorporated into the HV600, embedded in the system out of the box. You can hook up BACnet, Modbus, Metasys, and Apogee. And then we also option some communication cards as well. So LANWorks and Ethernet IP. And this collection of interfaces is really going to do a pretty good job of getting your system on the network with a building automation system or PLC in order to communicate with your drive and make changes whenever you need to. So getting into harmonics now, this is one of the kind of up and coming issues that we see with these inverter type drives. So I'm going to discuss what harmonics are and then some ways that we have been looking at mitigating them and, you know, options that people use in the field. Essentially, just to start right off the bat, you've got a fundamental sine wave. This is like a 60 hertz wave. This is what everybody wants. This is what you want your line to look like. However, we also have these small remnants of other frequencies. These are your harmonic waves that will then start to add on to this fundamental. And it starts to create a distorted waveform that can reduce efficiency and cause losses as heat. So to explain why this happens, it's important to look at a just general schematic of what goes on in a VFD. So just real briefly, you've got a sine wave coming in. This gets rectified with diodes to a DC signal. And then that's stored on a capacitor here, well, several really, in a HV600. And then what happens is you have an inverting section that uses a series of switches to then convert it back into a sine wave for the motor. So this is kind of the basis of it. And what we see is that in this system, you have these current spikes that come in, and it's no longer matching in current what the nice, pretty sine wave coming in it looks like for voltage. So this is what causes our harmonics. I'm going to speed up a little bit here just since we're getting close to the end. But again, yeah, so rectification, these diodes are what's causing the issue, generating these harmonic signals. And yeah, same kind of thing. So three-phase front end. The distortion levels are going to range 60 to 130% for a general VFD. And what's important about this is that it starts to infect neighboring utility customers. IEEE 519 is the industry harmonic standard that you want to meet. And a lot of Western states are becoming more stringent as we see more and more harmonic distortion on the grid. I'll actually skip this slide since I'm running out of time too. So the AC line reactor is first defense against harmonics here. And that's going to be a hunk of iron, like a big inductor. You're going to stick on the front end of the drive. This is going to help some improvement, but you're going to see more improvement with current distortion than you will with voltage. Again, so this is kind of the improvement you see, big humps in distortion down to more mitigated, attenuated distortion levels. The DC link reactor is almost the equivalent of the AC line reactor, but it's within the drive. The split link choke comes standard on the HV600, so there is some mitigation there. And yeah, so similar kinds of reductions in interference, kind of just a comparison of those two topologies. And then the one that people often use too is a high pulse count rectification scheme where you try to phase shift the different frequencies in order to cancel harmonics. So you might use a Y to delta and Y to Y configuration, phase shifted by 30 degrees, then you get cancellation harmonic signals that way. And you see a slow improvement here. The problem is that's really big and bulky. And what we propose at Yaskawa is to use a device called a matrix drive. So this is kind of a new technology. And so what we're doing is having bidirectional switches all the way down the whole phase list. And so it's kind of like, I think of it like Neapolitan ice cream. You take a scoop in real time of vanilla, strawberry, and chocolate. So phase 1, 2, and 3. And that gets converted almost instantaneously to the output phase going to the motor. So it's real-time power conversion, and this can go in reverse as well to take power from your motor back onto the grid. So this is the lowest harmonic option that we currently offer with Yaskawa, and we think it's pretty special. You can see we go from this configuration of high pulse count schemes all the way down to just one drive with 3 wires in and 3 wires out. And that's just a comparison here. The matrix is at the bottom in terms of harmonic distortion. 12 pulse and 18 pulse are pretty good, but don't quite match the matrix drives. And just a final comparison here, going from a regular VFD through that split link choke, multi-pulse configuration all the way down to the matrix, and you can see the improvement in the quality of the sine wave. All right, and yeah, we also, we provide lots of information on our website, Solution Center. We're always here to help at Yaskawa. Thanks for listening, and we'll go ahead and see what the prizes are this week. There we are. All right, thanks, Mike.
All right, David. Hey, I appreciate it. Please join us next week when we got Lindsay Flatter along here. If you want to know online on-demand ventilation, meet Aldi's Zone registered terminal. With that being said, if anyone has any additional questions on the harmonics and the HV600 drive, please don't hesitate to reach out to your long representative. And with that, we will cut the coffee break a little short today and move on to our Thursday. So thanks everyone for joining.